Position, Velocity, and Acceleration by Kara Gieseking. Position, velocity, and acceleration are all related to each other through rates. Velocity is the rate of change of position over a period of time, while acceleration is the rate of change of velocity over a period of time. You can use derivatives, which are defined as the rate that one variable changes in respect to another, to find these rates. You can also use integrals to do the opposite. Here's an example. A young Kevin Costner is driving to Miss G's house for their date when he realizes he has forgotten the flowers in his vacation house in Las Vegas. He turns around and goes to get them. On his way back, he crashes into an alien spaceship manned by Tom Cruise and is forced to run to Miss G's house. The following graph displays Kevin Costner's velocity in his trip to Miss G's house. At this point in time, I would like to point out that Kevin Costner does not heed any traffic signals or follow common courtesies that one would normally find on the road. Rather, he has his foot constantly on the accelerator and drives at safe speeds using only side streets. Now I'd like to point out some key things you should notice right away on the graph. First, where Kevin Costner turns around to get Miss G her flowers. A change from positive to negative velocity indicates a change in direction, so the cross at time t equals 2.5 hours indicates Kevin Costner's driving back. Next, where Kevin Costner arrives at his house. We can assume that at this point, Kevin Costner stands completely still and has his personal butler go find the flowers, since his velocity is 0 at this point. The butler takes a total of an hour to find Miss G's flowers. As you can see, there is no change in Kevin Costner's velocity from t equals 4 hours to t equals 5 hours. This is where Kevin Costner crashes into Tom Cruise's alien spacecraft. A car crash is usually signified by massive deceleration, which we can clearly see from the steep negative slope before a complete stop. This would indicate where Kevin Costner gets out of his car and runs to Miss G's house. His velocity running, as expected, is less than the velocity of his car, but he keeps up a constant pace of about 5 miles per hour for around 2 hours before he reaches Miss G's house, where he is finally able to stop. That's where he stops. We can find the acceleration using the derivative. Here I show you where Kevin Costner first leaves his house, reaching a max speed of about 20 miles per hour. You can find its acceleration by calculating the slope of the velocity, or its rate of change in respect to time. From time t equals 0 hours to time t equals 2 hours, Kevin Costner accelerates to a speed of 20 miles per hour, or accelerating at an average rate of 10 miles per hour squared. Finally, we use the integral to find Kevin Costner's total displacement. The integral describes the area under the curve, or the accumulation of change over time. So we first calculate how far Kevin Costner goes when he is traveling in the right direction. Then we subtract the distance traveling when he is going in the wrong direction. The two initial triangles should have equal area, as he traveled the same distance in each. If we were to find Kevin Costner's total distance traveled, however, we would find the absolute value of the integral, and just add all of the areas together.